Okay, so we are going to do the NAF2 sample questions. The questions I already showed it early on. So what we have here is MV Singapore. Okay, this is the vessel of interest. It says that vessel is anchored at 2.3 miles. Okay, southwest. Okay, southwest of Bedok Lighthouse. Bedok Lighthouse is our reference point. Okay, given the position of length and long 01, 18.5 minutes north and 103 degrees 56.0 minutes east. Okay, extraction of information. Extraction of information. So this 2.3 is actually called the distance. Okay, this is called the distance travel, or the distance towards the reference point, the Bedok Lighthouse. Southwest is actually the course, okay, of which we can proceed from Bedok Lighthouse towards the vessel. Okay, so southwest, we draw the 4 quadrants of the compass. Okay, so this is south and this is west. Southwest will be in this direction, southwest. Okay, so we need to know the points of the compass, and therefore this is the course. Okay, south 45 degrees west, or 180 degrees plus 45. This whole true course. Okay, that will give you 2 to 5 degrees true. Okay, so that's number one thing you need to find. So for the sketch, right, so it travels south direction from the Bedok Lighthouse. Okay, and from south it goes to west at 45 degrees. So okay, and this will be your distance. It traveled 2.3 miles. So this here is your difference in latitude, and this here is your difference, actually is your difference in longitude. But since this is not on the actual Mercator chart, this is just a reflect of a triangle. In trigo terms, this is called the departure, because the departure is actually in a ratio of the d long in reference to the difference of latitude. Okay, the higher the latitude from the equator, or the lower the latitude from the equator, the departure actually gets smaller. The only way where the departure and the d long is equal when it is on the equator. Right, so for trigo terms, for calculation of triangle terms, we call this departure. Okay, and later we will find the exact d long when we want to find the d long. Okay, so the first thing we need to find is actually the d-lat, because the d-lat is always constant, measuring from every latitude because of the great circle. So the d-lat, finding the d-lat, okay, we requires a trigo function. Okay, so what trigo function are we going to find? Okay, this is the trigo function. Okay, we have the tangent, the toit, or the car also. Okay, so what are these? These are, the T stand for tangent. Okay, so the O stand for opposite. If this is our angle of interest, so the opposite side will be the O, along its side will be the adjacent, and the longest side will always be the hypotenuse. Okay, so we want to find the DLET. We have the distance, so we have the cos. So we will use cosine here, car. We have the adjacent, we have the hypo, and we have the angle. So, written down in trigo terms here, the cosine cos is equals to the adjacent, which is the DLET, divide by the distance. Alright, so wanting to find the DLET, if I let the DLET stay and the denominator go to on the other side and rewrite it on the opposite side, so DLET will equals to distance times cosine cos, and rewriting that will have distance of 2.3 times cosine of acute angle here, 45 degrees west, and the answer will be 1.62635 minutes south. Okay, remember it's south to the direction. Okay, so at this point here, okay, this is your number 1 part 2 question. At this point here, after getting the DLET, okay, you can proceed on finding the mean let, or you can straight away plus the DLET to the initial position, and you will have your final position for your latitude. Okay, so but normally I would just proceed on finding the mean DLET. Okay, the mean in the difference of latitude. So I will take the DLET and I will divide it by 2, and I will express it in this term as 1.62635 minutes divided by 2, and we'll have 0.81317 minutes. Okay, south. And with what I'm actually doing is, after I find the difference in latitude, I divide the difference in latitude into 2, so I will have the center distance. This is the mean DLET, the mean of the distance between this latitude. Okay, and now what I'm finding is the mean let. Okay, the mean let is the actual position in terms of latitude. Okay, so what I'm going to do is the initial, I have the initial position, so the initial latitude, okay, whether it's going to be plus or minus depends on the latitude. I am on the north hemisphere, okay, my latitude is north. If I am proceeding north, the difference of my latitude is I'm proceeding north, then it only makes sense that I will be adding, and my latitude will be higher and higher. If I'm going downwards, or the opposite, if you have a north and you are going downwards opposite, it will get smaller. So that will give you an idea that you are going to put a minus sign from your initial position, because your DLET is minus. Okay, so on the opposite side you minus, on the same side you will plus. Okay, same for south, and south you will plus. You have a south and your DLET is north, you are going to minus. So you minus with the mean DLET. Okay, so you will have, this is your initial position. Okay, so you are going to minus this difference in latitude to find the position or the latitude format. Mean delete equals, okay, we write it into numbers. We have a 1 degrees 18.5 minutes north minus 0.81317 minutes south, and we will have the answer for the minlet as 1 degrees 17.68683 minutes north. So that is your minlet. Okay, so finding minlet is part of the question 1 part 3. Okay, and finding the minlet and finding the min delete. Okay, so what are you going to do next? For me, since I'm dealing with latitude right now, so might as well I find the final latitude. Okay, so the final latitude, okay, so the position of MV Singapore, okay, latitude position, okay, of MV Singapore equals to initial latitude plus d delete. Okay, so 1 degrees 18.5 minutes north. Is it plus or minus? Minus. Minus how many? Minus the delete. 1.62635 minutes south. Just now, what I do down here is finding this position. I divide the delete by 2. After that, I minus off this position and the difference in the latitude. I find this latitude position here. That is my minlet. Okay. Now I want to find the final position because the ship actually went all the way down here. Okay, on a southerly direction. So I take this position and I minus off the whole delete. I will find this latitude, which where the vessel will be on this gradient. So this is what I'm doing. So the answer will be 116.87365 minutes north. Okay, this is part of your answer in V. Yeah, 5. Okay, and now we will do the departure. So the purpose of finding the minlet is because you need to find the departure. Eventually we need to find the D-long. So before we find the D-long, we will find the departure first, right? So again, the departure will use trigo functions. Okay, because the departure is based on triangle rules. So we have a departure, and try not to use the answer that you generate yourself. Use whatever that is given. So the given is the distance, so we still use the distance and the cost. So the cost and the hypotenuse. Okay, the cost and the hypotenuse, wanting to find the opposite, so we use the sine rule. So sine, cosine, cos angle equals to departure divided by distance. Okay, so rewriting, we will have departure equals to distance times sine cos equals to distance is 2.3 times sine 45. Okay, and your departure is 1.62635 minutes west. Now that is your departure. Okay, so from departure we are going to find the d long. Okay, so finding d long, we cannot use the trigo function anymore. Finding d long, we will need to use the ratio, okay, between the departure and d long in reference to latitude. So what it means is that the d long and d lat in ratio of each other in reference to the cos mean lat. Okay, and therefore we rewrite, because we want to find the d long, so d long will equals to this is not d lat, this is departure. Yeah, so we have the departure going up I got this, I will rewrite again. Okay, so the cosine mean lat, okay, is equals to the ratio of departure and d long. I write it on the opposite side. So departure come up first and then d long. Okay, so having to rewrite, so we have a d long is equals to departure divided by cosine mean lat, and therefore rewriting the departure that we get is 1.6265 minutes divided by cosine mean lat, which is this mean lat, 01 degrees 17.68683, and the d long is 1.62677 minutes west. Okay, and after getting the d long, okay, we will find the longitude position of MV Singapore is equals to the initial longitude plus d long, okay, 103 degrees 56 minutes east plus or minus. So this is the longitude is west, so it's going to be minus, right, because of different sign. 1.62677 it's west equals to 103 degrees 54.37323 minutes east. Okay, and so we have solved question 1.